Welcome to the AI Infrastructure and Tooling panel. We have 4 great guests for you today to share some of their expertise on kind of, what goes on behind the scenes that's helping build some of these LLMs and evaluate and optimize them. So today we have Emma, who's one of the co-founders of Velvet. They are an AI gateway that helps you optimize your AI applications. We have Vig from Gradient Ventures, where they're doing seed investments into AI ventures and really evaluating where they're coming from. We have Andrew from Lastmile AI. They're a tool to help you evaluate, build models to evaluate your AIs and make sure they're doing well. And we have Lucas, who originally was in OmniML, which was creating efficient inference, but then got acquired by Nvidia. So now he's working with Nvidia to really kind of build up that infrastructure from, Nvidia is basically dominating the market right now, as we all know, so right at the core of it. So, to kick off our panel today, I wanted to ask all our panelists, as AI continues to evolve rapidly, how do you approach building infrastructure that's going to adapt to future advancements while remaining stable and usable for people today? And that's open to anyone to begin.
I can take the first pass at it.
Yeah.
Yeah. We've all kind of been in the AI space for a while, and so I think probably we share similar opinions where a lot of the core pieces for AI infrastructure are fairly common. You have your massive training cluster, and then you have some inference server, you have feature management, you have a model registry. It's all kind of common infrastructure. Now, things that change here and there are a bit nuanced for generative AI, but in general, we find that common pieces still exist. Mm-hmm. And so, at least for Lastmile AI, we really focus on problems that transcend, just specific to generative AI, but we want to make sure that it does kind of rooted in the principles of ML and AI, and that has been always quite sound. And so, that's kind of my take on it. I'm curious what other people think.
You go.
Yeah, I guess one of the things that it's very hard to answer this question broadly, but I think one thing that I've seen work a few times is vertical integration. So what I mean by that is when you're building infrastructure, being very cognizant and
Can you speak up a little bit?
Oh, sorry about that. So I was saying vertical integration. So what I mean by that in this case for infra is looking at where you sit in the software stack and thinking about the pieces above you and below you. We've seen a couple cases where companies have become more robust by approaching this, right? So Databricks, for example, starts as a software orchestration layer, and now it manages infrastructure as well. You have the ability to be more robust to workload changes like generative AI, right? Also going up the stack, you see a company like Grok, which is building further core infrastructure, building out a cloud, and that allows you to have larger scope, reach more users, and improve margins too. So I think being someone that really questions where you sit in a software stack, looking at what's above and beneath you, those are things that I generally think can help software businesses and infrastructure businesses in particular think about how they can be more robust to workload changes or new demand from customers.
I'm actually curious, how many people in the room are building with AI? And then how many people are engineers? Cool, that's helpful. I think something that I've learned from building a developer tool is that nobody cares about my vision. Nobody cares about the company I want to build from a customer perspective. What they care about is that I'm creating value for them. And so everything that we've built has stayed really true to solving customer problems that matter for someone today and doesn't matter for someone like a cool ML tool that you might want to use in the future. I don't know if that resonates with anyone, but the way we came to figure out what tools we should build was someone would tell us a problem and we would solve it for them. And I think that's a really big differentiator from a lot of what's on the market today, which is here's this really cool, flashy thing that you could create and use, but you have no application for it. So I think that's something that there's still a ton of room for in the industry in general, is how do normal people want to use AI? And then how does a pretty normal software developer want to use AI without becoming a researcher first?
I agree with everything that was said so far. One thing that's always strikes me as very interesting is, I think coming back to what Andrew said, is kind of the AI workflows we built. They have fairly standardized components, but for some reason, these standardized components aren't necessarily reflected in the software we use to write, build, train, and deploy AI models. And I find that kind of interesting because, there's a new flashy demo, a new model, and you can use it and run the chatbot with it, and then you compare it maybe to the demo you already have, and it looks like you have the same components across that demo, but none of these components really, interact with each other. Right? They basically, somebody came up with their own version from scratch, and they're fundamentally incompatible. And so, if you want to innovate on top of that, you are faced with trying to scrape together a couple of code bases that don't really interact with each other, or you might as well also just do your own thing from scratch. And so I see people repeatedly, building and innovating the same ideas. And what I at Nvidia tried to spend a lot of my time on is kind of drilling into that stack and understanding, hey, what are components that are truly reusable, and where do we have components that could be reusable but they haven't been invented or written yet. I think good examples are prompting techniques, or how do you do, I work a lot on inference optimization, so how do you, put together different LLM requests, how do you do fine-tuning, how do you do distributed workloads, and all of these things, how do you switch out models if a new model comes along, right? And all of these things seem very hacky at the moment. And so my ambition is that people spend more time understanding what components are truly useful in the long run. And I don't know if you have figured that out yet.
So it's interesting. A common theme I kind of saw in the answers there is when you're building an infrastructure is really thinking a lot about where are you building the infrastructure, like where is it in the tech stack, is this going to be a reusable component, how do we target it? And I'd like to double down on that. So let's start with Emma, with Velvet. And you said you were listening to customer problems, but how did listening to them help you decide exactly where in the tech stack to build? And kind of how did you stumble upon, this is the pain point we want to build for at Velvet?
Yeah, so we were building our own AI features to start in a more generalized developer tooling system. And we had to build all this baseline infrastructure ourselves because it didn't exist. So we had to build in logging, build in caching, build in our own testing and experimentation suite, figure out how to do fine tuning on our own. And we were just using OpenAI. So that really opened our eyes to how much baseline infrastructure and how early it really is. And then the reason we chose to be a proxy to start with, at least, is because it's 2 lines to integrate. So every engineer can try it in 5 minutes and get value immediately, as opposed to hiring an entire AI team to build and maintain all of these systems. So it was really just to solve our own problem and then solve our customer's problem as quickly and effectively as possible.
Sweet. And I'd like to jump to Andrew next. There's someone else who's building in this space. What's your similar answer with Lastmile AI? How did you stumble upon knowing where in the tech stack to build your solution?
Lot of attempts. No, and part of it is a little bit of intuition where a lot of us spend a lot of time in ML infrastructure and either deeper or higher level of it. Probably close to 7, 8 years in that. And so now I kind of have an intuition of what are problems that are incredibly difficult where a large company with a lot of capital are better suited versus what's a problem that we should tackle. So I guess it's a little bit of trial and error intuition, just over time going through the phases of each one and kind of understanding should we operate down to the GPU level? It's a lot of effort and a lot of work, and it's a historically challenging problem. So what's one step above that? What's one step above that? And where do we find that we'll add the most value, where we can tackle significantly challenging problems without going overly simplistic with it, as well as not challenge things as in let's bring another processing unit onto the industry and see if we can compete with Nvidia, because that's very, very difficult. We will not have enough money to do that.
And then my question for either of you to build upon that is, after going through so much iteration yourself to identify the pinpoint of the point in the infrastructure you want to build, do you find it difficult to explain to clients as to why they should employ your solution at that point in the infrastructure? Or do you find that businesses are quite understanding of that these are pain points they should be dealing with?
So for my take, it depends on the company. So certain enterprise companies have invested a lot into their ML infra or AI platform, and they already know what's challenging, what's not. And they've kind of hit a certain boundary where they need help something further along the line, further along the line. And so they will reach out to Databricks, they'll reach out to Azure ML or SageMaker team to try to get help. And so we find that those are good opportunities. For companies that haven't really explored AI or ML, they are looking for more of, we have a specific problem, can we get something more end-to-end that just solves it completely? So two very different things. And so a lot of the companies we sell to enterprise, and enterprises usually have put in some effort towards their AI or ML solution. And so we spend a lot of time to understand what they've tried and where they're at, and then find, do we fit into that, kind of take it a step further for them. Yeah, and so that's kind of where we slot in. And it really depended on our ICP, on who we work with, yeah.
Yeah, I would say similarly for us, we sell to companies who have gotten past product market fit and are heavy users of OpenAI, and that could be like the batch API, it doesn't have to be application layer. And so if someone's spending like $6,000 a day on OpenAI or any model, it's a really easy yes of like, they want to optimize, they want to make it better. They don't want to hire an entire engineering team to do this thing that's like not core to their business. And so that's a really easy yes. What's not as easy is if someone like says they do AI, but they have no usage. And it's hard to tell when you do a sales conversation of like, do they just say they do AI or do they actually do it? So that's been like a sales challenge. But once we get in front of the right person who is actually building real AI, it's a very easy yes with 2 lines of code.
And to follow on from that, I guess, for with startups at least, you're focusing on a more narrow ICP. At Nvidia, you're basically serving to everyone. So my question for you, Lucas, is how do you go about, and if you encounter this, explaining kind of complex technical deep topics to people who are new to the AI field or who may not understand or even view it just as a black box as to the importance of why they should invest in infrastructure and why they should optimize these AI outputs?
Yeah, great question. I think maybe I want to split my answer in 2 parts. I think from a technical perspective, what I think everyone should realize is that in the last maybe 10 or 20 years, a lot of the things that we have been running in the cloud were essentially, microservices and very small workloads. So the challenge was that, we have a cluster, and how do we virtualize that cluster so it can run millions of applications in parallel? And now we essentially did a 180, and with AI workloads is that sometimes now you have one workload running across the entire cluster, right? And so you have essentially the same complexity in terms of the application, but now that application needs to be distributed across an entire, cluster of 10s, 20, 30,000 GPUs. And I think that just underpins how much complexity goes into the infrastructure layer, right? Because even from a research perspective, if you look at how complex an AI model is 10 years ago and how complex it is today, if you just look at the algorithm, it's not many more lines of code, right? It's the same 1,000 line of code to define a transformer architecture and write a simple training loop. That hasn't changed, but now all of a sudden we want that to be mapped to thousands of devices. And I think that's really the challenging part today. And I think from a business perspective, and now also talking about Nvidia, I think that the part where you can really see the value of Nvidia is that Nvidia doesn't stop at the hardware level, but goes up into the software and infrastructure layer, right? And so even though the GPU cost of a Nvidia GPUs is really, really high, often what you see is that total cost of ownership with Nvidia is fairly manageable because you have that extra support layer in the infrastructure and software. You don't have to invest time in making multiple devices work together. And so I think there you can also see from the business side where AI infrastructure really makes a difference in terms of total cost of ownership that you spend on your training and inference cluster.
Yeah, and to pivot a bit and kind of build upon that, we're seeing the value here, but the question really is, the saying goes that in a gold rush you want to be the guy who sells pickaxes. And do we believe that this infrastructure is the pickaxes of the AI age? And I think I'm going to direct this question at Vig, as someone from Gradient Ventures. How do you determine, what are the pickaxes, and do you believe that infrastructure itself, like Lucas was describing, is really where investment should be going in the AI age?
I think so, but I think that one of the things that we heard a couple of times now is a lot of the components that make up, AI training clusters and data centers are common. A lot of the training software is common to other orchestration or scheduling or networking. So So one of the biggest questions that kind of goes through, I think, a lot of investors' minds is how do you escape competition, right? There is value to be conferred, but there's a few ways I think that I've seen competition be escaped. I think the first is you build a platform or set of infrastructure for a new audience, right? Snowflake and Databricks did this for AWS and Azure to compete with the BigQuery offering that Google had. I think the second is, can you build bridges or integrations that underlying platforms won't build, right? So Wiz, Okta, there's a large set of these companies that allow you to connect across platforms, right? Where an underlying platform may not have necessarily the incentive to move data or compute away from their platform. And I think the third is that I've seen commonly is, can you hyper-specialize for a specific developer persona, right? So Elasticsearch, MongoDB, these kinds of companies where you build for a very specific customer persona or developer persona, and you really pour a lot of effort into it, and it shows in the end product. So I think there is, I think, certainly money that should be directed and investment that should be directed towards infra, but I think the big question to answer there is how do you want to escape competition from, you know, the hyperscalers and big companies that have decades of experience, you know, working in the field.
And I think that competition kind of leads into a question that I think might broadly apply to everyone, because that's competition on the business level. But kind of on an individual level for engineers in the room or developers, how do you think that the infrastructure developers of the future should upskill to stay competitive and what they should be learning about? And how would you encourage organizations to foster the development of those skills for their engineers internally? And that's for everyone.
I think something we see with our customers is that developing software with AI is different in that you kind of start with a hypothesis, you go experiment, you come back to that hypothesis, and you do it over and over again forever. And so you have to really have this like experimental curiosity mindset that's a little different from the last decade of software development. And you have to have like product managers, designers, executives who also follow on that same structure. And so that's why having the data and understanding what to do with it and like running constant experiments forever is going to be the new reality. And the teams who can adjust to that most quickly will be the most successful at it.
I think that's a really good point. I think the analogy we can think of is maybe, you know, today if you compile your software, maybe it takes a couple of seconds, or maybe you don't need to compile it at all and just run it. Well, I think with AI, you do have a compilation step now, which is non-trivial, right? Which is training a model, fine-tuning your model, running experiments, you know, in whatever other way that incorporates AI and LLMs, which might not be on the scale of seconds, right, in order to see the results. And so I think we really need to adopt to that new reality and understand how can we build, you know, robust experimentation pipelines and exactly bring in that, you know, intellectual curiosity to really constantly innovate and run through these design and iterations and improve your product, you know, on a scale that's not seconds and milliseconds, but also not weeks and months, right? But maybe on the scales of a couple of days, right? You keep trying new ideas and keep iterating on, you know, what your AI model is capable of.
A really different response compared to both of you. I feel like just specialize on something that's really difficult because that will be still quite valuable. Maybe be good at building OS or work at like the low-level C++ or
What's some infrastructure examples? Something super specific and difficult that you do with the Lastmile AI that you'd want an engineer super talented in?
I mean, like, similar to like what Lucas talks about, if you can build a high-performance inference server, it's like very valuable. If you could build a highly distributed training cluster as well, that works super well, also really valuable. But yeah, I think the models are getting much better at code generation, but I still am not sure if it can replace some of those specializations because it is so difficult to do. And so, yeah, so my response is, if you want, on the individual level, as you're thinking about like, what you should do in the software engineering space. If you specialize on hard problems, and generally they'll still be hard problems. Yeah. If you start doing things that are more commonplace and it feels like a lot of people can do it, then I think that has the higher risk that AI can automate some portion of it.
Yeah, I think, I don't know about answering from the employer's perspective, but for, the employee or person who has a desire to learn more, I would say that one of the, really wonderful things about, the field is it's come out of academia and has a long and rich history that's really fully publicized, right? There's so many great papers that you can read that are free to read. There are so many great models you can try to work with on Hugging Face or other model surfing or model registries. There's a lot of information out there and a lot of courses that people have put together. I would say the really great thing about this process of AI discovery is that it's really a combination of many different fields working together, from distributed systems to machine learning to statistics to signal processing. There's a lot of information that it's free to access and it's free to learn. So I think being curious and being intellectually curious about the background of the things that you're working with can take you a long way.
Sweet. And at this point, I'll accept one question from the crowd before we wrap up this panel. If there's anyone out here who has a desire to ask the panelists while we have them here. Yep.
Sure. This question always have on me that the idea of quickly implementing AI and being able to play around with it versus, for long term, keeping your job, right, learning something very difficult. At the very least, as a blossoming developer, I think that first idea seems way more attractive. So what specifically would I look for if I wanted to, say, tell my boss, hey, I think we haven't implemented AI yet, but I could see a use case for it, and I want to give you a proof of concept in a month or two from now.
Yeah, you could get a proof of concept going without us. We don't help you do the proof of concept, but connecting to OpenAI, you could do that tomorrow, get something spun up, and take it to your boss. So I would recommend doing that. And then once you need to optimize, that's when something like our tool would come in helpful, where you would install it and then have insights into what's all the data running through this system, how do I make it better, how do I understand what's broken. But I would recommend just use AI tools to build AI. You can totally do that and bring it to them tomorrow.
Sweet. I think we have time for one more question, actually. So is there anyone else there who'd like to ask something?
So I think a lot of people in the media kind of generally talk about how AI has a lot of early adopters, but I think you're all in interesting positions where you might be seeing later stage adoption of AI. So can you kind of speak to what you're seeing beyond kind of the early adopter startups in the market? Are big companies in Fortune 500s deploying AI? And are they deploying it as a toy, or is this making a meaningful impact in the businesses?
I would love to take a pass at this one. So this is why we created Lastmile AI, which was, the naming was, it's easy to get something up and running, but this last mile of work is significant and quite challenging. And so as we work with enterprise, we find that that last mile of work is enormous. And so the margin of error, what these enterprise companies can, especially if it reaches their customers, even with internal tooling, they find it extremely challenging. The amount of adoption is still high. They're all trying out different models from different model providers and different tooling on it. The success rate that they've experienced with actually getting these applications live is quite low still, because it's so challenging to cross that last chasm. I would say, the general 80-20 rule for generative AI, it almost feels like a 95-5% rule, where it's the first time you run a query to OpenAI, you're so impressed, and then you might be give me a code snippet that does this, and you're like, oh, this is amazing. And then when you're trying to get your enterprise to adopt it or get in front of customers, you find a long, massive tail of edge cases, issues, the ways you add data, and you're kind of building this massive amount of infrastructure and tooling to support that. I think over time, it's hopefully going to get easier. I think Lastmile AI plays a role there, where we want to simplify it, because everyone can see that value, but it's just out of reach for a lot of enterprises. So how do you cross that chasm? And it turns out it's a lot of things that have been built before at large tech companies, because outside of generative AI, it was traditional, ranking algorithms, different like fraud detection algorithms, and they all had these long-tailed edge cases. It's just now every other company's experiencing it, and so that's my take on it. Curious to see what others have.
And with that, we're going to have to wrap up because we're in time now. But I think that's a good note to end on, the last mile to keep going afterwards. So I'd like to everyone to thank our panelists for their time today.